this lesson, we are going to learn how to assign oxidation number to a specific atom in a chemical formula. But first of all, we need to look at the rules that we need to follow through to assign the oxidation number. Now notice how they are very similar to the charges of ions. And that is because oxidation number tell us if an atom is going to lose or gain a specific number of electrons to be stable. So go ahead and pause it and look at the rules carefully before we start doing some practice problems. So here I have this chemical formula, H2SO4. First of all, we need to break them apart based on what we already know. We know that hydrogen, when we look at hydrogen, is bound with a non-metals, so it has a +1. So we know we can apply that rule. So that is +1. Now, notice how this consists of 3 different types of elements, but the total, this is a neutral compound, so the total must be equal to 0. So I can prove that hydrogen has +1. But in this case, it has 2 of it, so it's +2. But the oxidation number for hydrogen is still +1 because we are looking at just one atom. For sulfur, we don't have any rules for sulfur, but we have oxygen, so we have the rule for oxygen. Notice how oxygen only in peroxide has -1. That's like H2O2. That's the time when we see oxygen is -1, but the rest is -2. So oxygen has a -2, but we have 4 of it, so that means we have a -8 total. So this is for the total of oxygen, this is for the total of hydrogen, and sulfur, we don't know what it is, but we know it's gonna be X. So in this case, we're gonna add X to it. Can we solve for X? Well, of course, we have +2 and -8, that cancel out and give us -6. And X is gonna be what? What number plus -6 will give you 0? Of course, X must be 6. So it turned out that the oxidation number for sulfur is gonna be +6. So our final answer is, in terms of assigning oxidation number, is hydrogen is +1, sulfur is +6, and oxygen is -2. And notice how we don't care about the subscript 2 and 4 when we look at the oxidation number of each atom. Let's try another problem. Here I have a more complicated problem. I have nitrogen, hydrogen, and chlorine. So in this case, I know that hydrogen, when it's bound with a nonmetal, it has a +1. So I can say that is a +1 right there. And for chlorine, we don't have a specific rule for chlorine, but here's a common one. Notice how fluorine is the rule is always -1. This also applies to the halogen as well. So chlorine is in the halogen, but this rule specifically talks about fluorine. That is because fluorine always has -1, but most of the halogen always, or most of the time, follow this rule as well. So it turned out halogen switches chlorine, so it's -1. So if that's -1, let's go back and do the math, okay? So the totals add up equal to 0. Now what if I put a coefficient here like 3? Do we care about that 3 at all? No, because we're looking at individual atoms, okay? So we have -1 for chlorine and +1 for hydrogen, but we have 4 of it, so that's going to be +4, and we don't know anything about nitrogen, so it's going to be X. Now, do I care about -X or +X? Of course, to represent a variable, it has to be plus, so we can solve out the negative later. Notice how I have just X for nitrogen because we don't know if it's going to be positive or minus, but we can solve for that. So here we have 4 and -1, that cancel out, that gave us +3. So what is our n gonna be? Of course our n is gonna be -3 because -3 plus 3 gives us 0. So X is equal to -3. So our nitrogen has a -3. And that is all we have to do. Let's try another one where in this case I have an ions. So notice how we have -2. So our total must be -2. And we don't know anything about chromium, but we know oxygen. So go back to oxygen. It's -2 in other compound. So oxygen is -2, but we have 7 of it, so that's -14. And then we have chromium. Notice how we have 2 of it. So we're going to put 2x. Can we solve for x? 2 times what? -14 will give us -2. And that, of course, is going to be 6. 2 times 6 gives us 12. And that -14 gives us -2. So chromium, one single atom of chromium has a +6. And one single atom of oxygen has -2. And again, if I put a 5 or whatever number right there, it doesn't really matter. Let's try another problem. Here we have CH3OH. Notice how we have hydrogen in 2 different places, but the rules still apply. So we have hydrogen plus 1, and we have hydrogen plus 1. And again, the total is equal to 0. So here we have 1 hydrogen, so we have another 3 hydrogen here. We have to total that equal to 4 plus, or plus 4. Then we know the rule for oxygen, which is going to be -2. So we have only 1, so it's -2. And we don't have a rules for carbon, so we have to realize we put an x there. So what is x going to be? Of course, this cancel out, give us +2. So x must be -2. The -2 and +2 give us 0. So we have C equal to -2, H equal to +1, and O is equal to -2. And again, if we have a number right here, it doesn't really matter. Go to StreamlineED.com to download ready-to-use online practice with immediate feedback. You don't have to make copies. All of your student work is auto-graded. This will save you a lot of paper and hours of grading. The links are in the description below. Thank you.